This is a production of Cornell University.
So, I've introduced you to these soils. Let's actually talk about how they are in fact related to each other. Okay? And generally we sort of just show this by basically a sort of a temporal trend here, a longitudinal study. We start over here. This is very slight weathering. Over here, strong weathering. So basically what you're looking at is a degree of intensity or soil weathering. Okay? So degree of weathering and soil development. Okay? So let's start on this side. Okay? Very slight weathering. We basically have the entosols, recent. Okay? This is the fresh deposit. Okay? Now, there is a break right here between this soil and that one soil at the top because all of these 11 that are all tied with this arrow, these are all mineral soils. The one that's on top is the histosoil. Those are organic soils. Okay? Or basically, with organic soils, you're basically looking at a deep accumulation of organic material. It doesn't talk about what kind. It's just a deep accumulation of organic material. Okay, so let's talk about the mineral soils. The very first soil, i.e. the first deposit, what happens to this material, or how do we classify it? We call it an entosoil. Now, if I have weathering occurring to this soil, depending upon what kind of weathering, if it is mild weathering on volcanic material, we call it an endosoil. So that first volcanic event that deposits everything, it's still an entosoil until it starts weathering into the endosoil. Okay? On the other hand, if I have this recent deposit of material and it's in a cold area where I might have permafrost, and I have any kind of cryoturbation or permafrost, we call it a gellosoil. The frost is producing a diagnostic feature of that soil from the entosoil. It now has diagnostic features. It's got 4 legs or ears or whatever it happens to be. It's now a gellosoil. If I have mild weathering in various conditions, not volcanic material and not cold, we move from an entosoil into an inceptosoil. I'm seeing the beginnings of soil horizons. We have more weathering. We start seeing more and more weathering. And I start seeing clay accumulations. I start seeing alpha soils. If I have more and more and more weathering, I start seeing ultisoils. Entosoils through inceptosoils. From inceptosoils, we go to alpha soils. We started having accumulations of high activity clays. The weathering continues. Those clays start weathering out, and we start getting to low activity clays. And we get ultisoils. Does this make sense so far? OK. I'll take that as a no. No, really. Are we starting to see the trend here? All right. Now, if we start with our entosoils, and the weathering produces a specific kind of clay that has this shrink swell capacity, high base saturation soils with high activity clays, we basically have vertisoils, expansion, contraction, expansion, contraction. Okay? I will be showing pictures of this so you can see these soils. These soils tend to be dark just because of the nature of the clay, okay, and the organic matter that's in them. Okay. If this entosoil is subjected to a grassland climate where I have lots of grasses, so it's semi-arid to arid, but it's still got a little bit of moisture in there, I start having grasses. Those grasses dominate the soil formation and basically produce mollisols. If instead of dry environment, I get a cool, wet environment, and I have sandy parent materials, I start forming spodosoils. And in time, all of these soils, if the climate and the landscape is fairly stable, sooner or later, all of these guys are going to become oxysoils. Now, the way this flowchart spreads out, it makes it look like all of these go to end states. It's going to get here, and it's going to be a mollisoil, and it's going to be a mollisoil forever. The reality is, all of these soils, including the oxysoil, can undergo some sort of disturbance and go right back to entosoil. Or any one of these soils can go under some kind of disturbance and actually move from iridosoils into alpha soils, or iridosoils into mollisoils, or mollisoils into alpha soils. Okay? This is not a flow chart to the end. Okay? You can start here, you generally end there, but all of these spots, something can happen to them. The climate can change, some sort of stochastic event, a landslide or something like that can happen and basically start this cycle all over. Does that make sense? Yeah? Thank you for the response. Go.
But for the inceptisols, is inceptisol basically like phase 2 of soil formation if entisol is the first?
Yeah, I mean, the question is inceptisol basically sort of phase 2 if entisol is the first? In a sense, you can think of that. And in fact, most of these soils, the first thing you're going to see is inceptisol. Okay, yeah, it may phase fairly quickly into an andisol or vertisol or gelosol or something like that. But usually this is the incipient conditions. Okay, this is where you see those BW horizons. Remember, we've all been introduced to BW. BW, weak color or structural development. Okay, we saw it right underneath that AP horizon in the arc port. Okay, you're going to see it very pronounced this week. Feel comfortable with this? Now, this is the flow chart of weathering and development and soil development. This is sort of a box chart looking at sort of climate versus temperature. So moisture versus temperature. We're basically looking at climate. Okay? And the way to think about this is imagine this slide right down here. What is actually driving this? This is not a timeline. Okay, we sort of portray it as a timeline, but this is really intensity of weathering. Okay, I could have an environment that's been there for 1 million years, but no weathering occurred. Think of a dry desert environment. On the other hand, I could have a climate that dramatic moisture, hot temperatures, weathering is going to be a lot faster. Does that make sense? So in that scenario, I'm going to be driving the system that way a lot faster than I would be in the desert. Okay? So let's actually look at what the climate does to where these soils are. So let's imagine a very intense weathering environment. I would imagine a warmer temperature, maybe even hot, certainly a moist, perhaps not drowning underwater, but a moist environment. So if we think about that, warmer and wetter, what do we end up with? Those oxasols, right? On the other hand, let's put the scenario where I have an environment, very poor weathering environment. So cold, dry environment. Okay? Not a lot of stuff is going to be happening there. Cold, dry. We've got gelosoils. EIH basically means entisols, inceptisols, and histosols. We're looking right in here. Does that make sense? Yeah? Now, if it's a cold environment, it doesn't matter if it's wet or dry. Okay? I'm still going to get those frost, that frosted environment. Okay? As it gets hotter and dry, I'm going to move right into these andisols. Okay? As it gets hotter and wet, I'm going to start moving in. Basically, if you follow this trend right here, I'm going to go straight through alpha soils into ultrasoils and ultimately to oxasoils. Does that make sense, that arrangement? In essence, we're just basically doing a pseudo degree of weathering and soil development. Go.
So the vertisoils are vertisoils are like that anywhere in that area?
Sort of, we find them sort of in here.
So how do you get that versus getting like an alpha soil?
Well, vertisoils so the question is, how do we get the vertisoils versus alpha soils or ultrasoils? Vertisoils are clay soils, but they're a very specific kind of clay.
So it's just if that clay happens to be there.
This happens to have a lot to do with the parent material, but you also have to have the climate to produce those types of clays. And they tend to be centered right in this zone. Does that make sense?
Yeah.
Okay. Sounds good? Vertisols are interesting. Generally, we think of these sort of down in Texas in that area. But actually, we have a lot of vertisols in western New York. There's a whole development that got put on these vertisols. And basically, all the basements are being ripped apart, or were being ripped apart. Imagine you put a material on something that's going to shrink and swell every time it rains and dries up. What do you think it's going to do to your foundation? It's going to rip it apart. Okay? And New York State, you never would have thought that would have occurred because we don't have, well, we do have the right climate, but we're fresher material. You wouldn't think we'd be producing these types of clays, but we in fact do have some of those clays up here.
This has been a production of Cornell University, on the web at cornell.edu.